This question is to examine the properties of antiderivatives when the original function. Please subscribe to our YouTube channel Math Tutor 8285. Your subscription fuels the passion. Let's grow together. Thank you so much. Let f of x be a continuous odd function. Which of the following statements is true about all antiderivatives of f of x? There are four options. First, we start by using the fundamental theorem of calculus. Since f of x is continuous, we can define a function capital F of x as the definite integral from 0 to x of f of t with respect to t. This function capital F of x is one of the antiderivatives of f of x. Next step is to examine the symmetry of the antiderivative. To determine if capital F is even or odd, we look at capital F of negative x. This is defined as the definite integral from 0 to negative x of f of t with respect to t. Now, we perform a change of variable. Let u be equal to negative t. Then, t becomes negative u, and the differential dt becomes negative du. The new limits of integration change from 0 to x. Therefore, capital F of negative x becomes the integral from 0 to x of f of negative u times negative du. Then, next step, use the oddness of the function. Since f is an odd function, f of negative u is equal to negative f of u. Substituting this into our previous expression, we now have the integral from 0 to x of negative f of u times negative du. The two negatives cancel out, so this simplifies to the integral from 0 to x of f of u with respect to u, which is simply capital F of x. So, capital F of negative x equals capital F of x, which means capital F is an even function. After that, next step is to consider all antiderivatives. Every antiderivative of f of x can be written as capital F of x plus a constant c. Adding a constant does not affect the symmetry of a function, so all such antiderivatives will also be even. Correct answer is C. They're all even functions. A common misconception is to think that the integral of an odd function must also be odd. This is not the case. Integrating an odd function can change its symmetry. If you integrate an odd function starting from 0, the result is always an even function. Symmetry wins. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Your subscription fuels the passion. Let's grow together. Thank you so much.